Welcome back all. This is Muthuminal, Assistant Professor at the Department of Agricultural Engineering. Today we'll see something about soil water retention, and this is the topic which comes under the subject Irrigation and Drainage Engineering for third year Agricultural Engineering Department students under the unit Soil Water Retention and Measurement of Soil Water. Before going into the session, we have a small recap what and all we have seen before at the previous 5 sessions. I hope you guys will remember that we have seen something about why irrigation is necessary and how the water and soil gets interacted, what could be the interaction that happens, what are the primary ways of soil water and what force acts over the soil water to get drained off, and also we have seen something about the water holding capacity. Today we will see about what is retention. From the word itself, it is really clear that whenever a water has been poured over a soil, there is a period of time that the water gets retained at for a few period of time. So that term is said to be as retention. So if that is the case, it is a property where the soil holds moisture due to their colloidal properties and aggregate qualities. Usually, this is held on the surface of the colloids and other particles under the pores. This happens depending over the soil's nature. Purely, it is capable of only this kind of nature or the surface of the soil. The forces responsible for the retention are usually surface tension and surface attraction, which are described in different energy concepts. One is after the drainage due to the gravity has stopped, and the other one is caused due to the surface moisture tension. The force with which the water is held is also said to be as a section. This is a comparison between two types of soil and what would be the capacity of soil to hold the water. When a soil texture differs, then there will be certain effect in the water holding capacity also. As I have shown here, there is an example of coarse sand and silty clay loam. We all do know that coarse sand is one where the soil has a very huge pores while compared to that of a clay. But in clay, the pore size will be in a very reduced manner. Usually, the dry soil and the gravitational water holding capacity, unavailable water, available water, everything is same for both the nature of soil, but only the availability gets varied due to the size of the pore. This is what I have shown here. For a coarser sand, the holding capacity is more while compared to that of a clay sand because there is a reduced size in pores which has a inability to utilize for a growth of a crop. Usually the gravitational water is available for the soil moisture that could be absorbed by the plants, but that won't be available here because of the reduced pore. This is what happens everywhere, and the soil water retention also changes. This is what I have prepared for today's class. See you at the next class. Thank you. At the next class, we will see something about what are the retention ways and how the soil will get settled at the bottom of the soil texture, and how could the soil moisture will be observed with the help of either gravitational force or the capillary force. The retention ways will be of four types. Those will also be studied, and I will give a detailed explanation over it at the next two sessions. That is what are the retention ways and what how the cohesion and adhesion forces acts in upgrading the soil moisture, and also however the texture and what we can do in order to increase the crop yield with the available soil moisture, and what could be the rate of infiltration. These are something that could be studied by us in the next session. Thank you.